So in this example, now we're going to reverse engineer the process we've already looked at. Now we're going to take a graph of a function and determine its equation. So what I've done for you is in blue I have given you the standard radical function. Points at 0, 0, points at 1, 1. I've neglected to put the arrowhead on the right side just because that is the way the source that I pulled them from presented them, but it is there. So what we need to look at on the transformed functions is, does the point differential, the distance between the points, match up to the original graph? If it does, then we don't have any stretches. If it doesn't, then we do have stretches. So knowing that we have points at 0, 0, and 1, 1 normally, we won't have points at 0, 0, and 1, 1, but we will have points that are 1 unit to the right and 1 unit up from each other. Is that the case? Well, our starting point on the red graph is down here. We have another point at 1 to the right and 1 up, so we do not have any stretches. All we have in this case are a couple of shifts. So we have shifted to the left. If we just start counting, we've shifted to the left by 5. And we've also shifted up by 6. Looking at the equation, which I'll write out in its full form, y equals a square root of bx minus c plus d. The only transformations we have are a c and a d. A and b are non-existent, so we'll have y equals the square root of x plus 5 plus 6. Look at the second example. Again, blue graph being the original. We have our standard points at 0, 0, and 1, 1. In our transformed graph, we have our initial point here, and our second point is 1, 1 away, but it's 1 to the right and 1 down. So we actually have a vertical reflection here in order to make that happen. No stretching since the distance between the points is the same, just now we've moved down instead of up. It gives us the reflection. Looking from our starting points, we have shifted to the right by 5. And we have shifted up by 3. Filling in our A, B, C, and D, we do have A this time. Vertical reflection would be a negative. No horizontal stretch, so no B. But we will have x minus 5 from that horizontal shift, plus 3.